Hello everyone, welcome to CodeSoft. In this video, we will be discussing about two-dimensional arrays, and students from Java, C or C++ background can watch this video because we will be discussing the general approach to two-dimensional arrays. The first thing is, what is a 2D array? So going by the definition, a 2D array is similar to a 1D array, but it can be visualized as a grid or table with rows and columns. So our 1D array was present across a single dimension, that was the x-axis. So all the elements were present in a single row, that is only on the x-axis. But if we talk about the 2D array, it will be present across two axes, that is x and y. So you will find elements that are present in different rows as well as different columns. So if I show you a glimpse of a 2D array, so this is how a 2D array looks like, right? So there are 4 rows as well as 4 columns in this 2D array. So if you compare this with the 1D array, the 1D array was having only single row, that is the first row, and there were only elements present across different columns. But in this 2D array, there are also different rows and there is a distribution of elements across the columns as well as rows. Now, how do we declare this array? So 2D array basically has two square brackets, one referring to the number of elements, that are number of rows present in our 2D array, and the other one referring to the number of columns present in our 2D array. Right. Now, next thing is, how do we actually iterate through this array? That is how each element will look like in a 2D array, right? So basically each array is characterized by two things, that is its row number as well as its column number. So if we talk about this, let's say this element, that is ARR1 1. So the first one refers to the row index, that is second row, and the index will be 1. Since the arrays are indexed from 0, not from 1, so second row will have an index of 1. So 1 is the row index and the second index is 1, that is the column index. So this element is having 1 as row index, 1 as column index. Now if we talk about this element, so this is having the third row or the second row index column, and so second row index, and the column index is 1 because it is the second column, right? Similarly, the first element will be ARR 0, 0, that is 0th row, 0th column, or first row, first column with 0 as indexes, right? And the last will be ARR 3, 3, that is the nth row and the nth column, that is the fourth row, fourth column with 3 index, right? So this is how an array goes like. So if we talk about the general traversal, how the traversal goes like, first we go to the first row, then traverse all the columns one by one, right? For when we reach the end of the first column, we move our row one step ahead, we move to the next row, then start traversing from the first column till the last column. Then we move to the third row from the first column till the last column, and similarly for all the rows. This is how we traverse our array in our 2D array in any language, right? So if I talk about the basic code of this will be, so first we need to declare our array int ARR n and m. Now n refers to the number of rows, that is the maximum number of rows that can be present in our particular 2D array, and m refers to the number of columns that will be present in this 2D array. After this, so if you compare this to a 1D array, there was a single iterator I or anything that used to start from 0th element and go till the last element, and this is how we used to traverse our array, right? But in a 2D array, we will require 2 iterators. One iterator will actually be calculating the current row number, and the other iterator, that is the j iterator, it will be storing the current column number. So with the help of both these characteristics and with the help of both these iterator, we declare a particular element in our 2D array, right? So we declare I and j, int I for storing the current row number and j for storing the current column number. After that, we start the first loop, that is I equals to 0, that goes till I equals to n. So this is basically the row loop. So if I talk about if I compare it to this array, so as I told you, first we will go to first row, then second row, then third row, then fourth row, right? So this traversing of rows will be done through this first loop, that is the I loop, right? After this, inside each I, like let's say I equals to 0, we start another j loop. This will be the column loop. So what we are doing is, we are going to each row and then traversing all the columns, then going to the next row, traversing all the columns, right? So j will start from 0, j will go till m, why m? Because m is the last column number, right? And then j plus plus. So this is the loop for j, or the columns inside each row. And inside this we'll just print arr I comma j, where I refers to the row number coming from this loop and j refers to the column number coming from this loop, right? So C++ students can write cout and Java students can use the SOP or system.out.print statement. After we complete any loop, that is any internal loop like the j loop or the column loop, we actually print an empty line. This is because after each inner loop or after each column loop we need to move to the next row, and next row comes on to the next line. So that is why we are printing an empty line after each column is completed or after each row is completed, right? So this is how our 2D traversal looks like. Similar to 1D, just there is a nested loop instead of a single loop for traversing our arrays, right? Now moving on, what is the link between dimensions and loops, right? So one thing is that this was a 2D array, but there is a possibility that there could be a 3D array where there are elements present in the z axis. There can be a 4D array where where a new axis can be defined, and there can be n number of axes, right? Elements can be present across n number of axes, right? So in those cases, how we will traverse it? So basically there is a link between dimensions and loop. So for 1D array, we have a single loop, one for loop. For 2D array, we have a nested loop where there are two for loops, right? Like the one we saw in the previous slide. For 3D array, we will have a nested loop with three for loops nesting one another. Similarly, for ND array, we will have n for loops that are nesting, and each for loop is inside another for loop, right? So that is a nested loop containing n for loops. So this is how we can link the dimensions with loop, right? Moving on, another important thing is that how do we store the 2D array in memory? So we know that our arrays are called as continuous memory allocating elements, right? So in 1D array it was very clear that we will have we will just calculate the memory of, we will just find the address of base element or the 0th element, and then we can add the number of bits present inside the data type for each element and traverse one way, right? But in case of a 2D array, how can we actually put our elements into the memory? Because this is a 2D array, and talking about the array rule, it should be continuous also, right? So what happens in this case is, this is the base element or the 0,0 element or the first element of the array. This gets any address allocated randomly. So let's say the address allocated was 0. So this element will be present over in this memory area, right? So next element will be present on the next area, the next will be present on next area. And once we complete a row, we do not go to some different column in memory or some different row into the memory. Just the next memory address of this 3, we will place our fourth element or the next row's first element. Similarly, when we will we'll go to 7, we will just place 8 into the next stop of 7. That is, the continuous allocation goes on. So if we are 7, 8 is also coming on to the next address, right? So this is how we allocate any memory, any 2D array in our memory addresses. Now if we talk that, let's say, what is the formula for calculating memory of any a of I comma j if a of 0,0 is known? So let's say the base address is known and you want to randomly find the address of any element that is present in the same array. So if I talk about, let's say we want to calculate the element that is present at 13, correct? So the address of 13 if address of a of 0,0 is known. So the formula is memory of a of I comma j is equal to memory of a of 0,0, that is the base address, plus size of data type. So size of data type matters because let's say we are having an integer data type. So each element of the array will be given 4 bytes, and if it is a character 2D array, so each element will be given 1 byte of data. So that is also mattering. The size of data type into I into m. So I into m refers to all the rows that are present above. So let's say if you are at the third index row, right? So there are 3 full rows above this, right? So I is equal to 3 and m is equal to 4. So basically you want to cover the addresses of all the 3 rows above. So that you are doing with the help of I into m. So I into m refers to the grid just above yours, right? So if we are at this row, so the above grid, that is this grid that I am marking, so this grid is coming from I into m. So we have covered this grid. Now we just have to cover the elements that are present in our current row. So that is till j. So j will be referring the current column number. So we will just add j to it. J will be the number of elements that are present in our current row in which we are calculating. And also we are multiplying all this I into m plus j into the size of data type that will be actually mattering. So this is how the formula can be used to find any memory address of a of I comma j. And this is about 2D array, so it's just a grid. And in the upcoming video we will be watching how we can solve questions of 2D arrays and what are the different questions that we actually discuss. So thank you. That's all with this video. Thanks for watching. Stay tuned to add more festoons into your knowledge garland, and till then please keep subscribing. Thank you.